Today in this session we will learn about 3 to 8 line decoder. The way we are going to learn about 3 to 8 line decoder is, first we will see the design of 3 to 8 decoder, then we will see the design of 3 to 8 decoder with the enable input, then we will see the design of 4 to 16 line decoder using 2 3 to 8 line decoder. Then next we will see 5 to 32 line decoder using 1 2 to 4 decoder and 4 3 to 8 line decoders. Then we will see the design of 6 to 64 line decoder using 9 3 to 8 line decoders. Then we will see the design of full adder using 3 to 8 decoder. Then we will see the design of full subtractor using 3 to 8 line decoder. Then we will see the design of 8 to 1 mux using 3 to 8 line decoder. Then we will see the memory mapping using 3 to 8 line decoder. Then we will discuss some examples of implementation of Boolean function using 3 to 8 line decoders. Imagine you have a key that can open multiple doors, but you need to choose the right door every time. A decoder is like that key in the world of digital electronics. It is a clever device that helps us make decisions and select the right path for digital signal to follow. A decoder is a combinational circuit that conveys binary information from n input line to a maximum of 2 raised to n unique output lines. The 3 to 8 line decoder takes the concept of decoding digital signal to the next level by handling a specific 3-bit binary input and producing an output with 8 possible combinations. Now, we will see the truth table for design of 3 to 8 line decoder. We will consider A, B, C are the 3 inputs, with A be the MSB and C be the LSB bit of the input lines, and Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7 are the corresponding output lines. The ABC input will varies from 00 to 111, and for the input 00, when A is 0, B is 0 and C is 0, the output Y0 will be activated and set to logic 1. For the input 001, the output Y1 will be set to 1 and all other output will be at 0 logic. Then for next, when A is 0, B is 1 and C is 0, that time Y2 will be at logic high and all other output will be at logic 0. Similarly, for the case when A is 0, B is 1 and C is 1, in this case of input, Y3 output will be at logic high and rest all other outputs will be at logic 0. For the input when A is 1, B is 0 and C is 0, the output Y4 will be at logic high and remaining all other output will be at logic 0. For the input when A is 1, B is 0 and C is 1, the output line Y5 will be at logic high and rest all other outputs will be at logic 0. For the input when A is 1, B is 1 and C is 0, that case the output Y6 will be at logic high and rest all other outputs will be at logic 0. And for the last, when A is 1, B is 1 and C is 1, in this case of input, the output line Y7 will be at logic high and all other outputs will be at logic 0. So, this is the truth table that we have seen. According to this truth table, we will now see the design. The implementation of 3 to 8 decoder can be done using AND gate and a NOT gate. The input A will be directly connected to all the inputs of AND gate, then A bar will be connected. Similarly, the input B and B bar, C and C bar. So, for first AND gate, right, which is correspond to the output Y naught, the A bar, B bar and C bar will be connected with the input of first AND gate. Accordingly, for the second AND gate, A bar, B bar and C will be connected, so that we will get the output Y1. For third AND gate, A bar, B and C bar is connected, so that we will get the logic output Y2. For fourth AND gate, A bar, B and C are connected, so that we will get the output Y3. For fifth AND gate, logic A is connected, then B bar and C bar is connected. So, we will get the output Y4. Accordingly, for next 6th, 7th AND gate, the A and B, in addition to that C bar is also connected, so that we will get Y6. And for Y7 output, A, B, C are connected. So, accordingly, the design is done for 3 to 8 decoder and will get the output correspondingly as the input is present. Now, we will see the design of 3 to 8 line decoder with the enable input. Why? Because if we have to connect, right, make the use of 3 to 8 decoder, right, for some other combinational circuit, when 3 to 8 decoder has to interact with the other circuits. So, that time enable input plays a crucial role. So, now we will see the truth table of 3 to 8 decoder. So, in this case, for 3 bit input, we have one additional input that is called enable. So, accordingly, we can say there are 4 inputs, right, but in this case when the enable is at logic 0, irrespective of whatever the value of logic A, whatever the value of logic B, whatever the value of logic C, means A input, B input and C input are do not care, and no output will be activated. And when enable input is at logic high, that time according to the input of A, B and C, the corresponding output will be activated one at a time. For the case first input 0 0, Y naught will be activated. Next, for logic 1, the Y1 will be activated, and accordingly for the last output 1 1 1, the Y7 will be activated. So, this is the truth table of the 3 to 8 decoder with enable input. Now, we will see the implementation or gate realization of this circuit. You can see the design of the 3 to 8 decoder, right, is almost same as what we have seen in the earlier case. only here the enable input is additional. So, the AND gate that we are using for 3 to 8 decoder design with enable will require 4 input AND gates. So, we will have 8 4 input AND gates and the input A, B, C and enable is connected. Now, this enable input is connected to all the 8 AND gates and the input A, B, C is accordingly connected. For first it is A bar, B bar, C. For Y1 output it is A bar, B bar, C. For Y2 output it is A bar, B, C bar, and accordingly all the connections of AND gate is done that we have done in previous case. So, this way the design of 3 to 8 decoder with the enable input is completed, and when the enable is high, that time the decoder will work, and according to the input it will give the one corresponding output. Now, we will see the design of 4 to 16 decoder with the help of 2 3 to 8 decoder. How this design is done? See, 3-bit inputs are there with one enable input. So, what we will do? We will consider the 4-bit input for 4 to 16 decoder, that is A, B, C and D, being A be the MSB and D be the MSB and A be the LSB. So, the MSB bit of the 4 input is connected with NOT gate to the first decoder, and the MSB of the 4 input is directly connected to the enable pin of the second decoder, and input ABC are simultaneously connected to the 3 input pins of the 3 to 8 decoder. And for first decoder we get the output, let us say if we consider the output D0, D1. So, first decoder will give output D0 to D7 and second decoder will give output D8 to D15. So, this way the circuit is realized for 3 to 8 using 3 to 8 decoder for 4 to 16 decoder. So, according to whatever the 4 input, the one corresponding output will be activated. Suppose we have all the inputs A, B, C, D are 0, 0, 0. So, from first 3 to 8 decoder, D0 output will be at logic high. Suppose we have input when D is 0 and all A, B, C are at logic 1. So, in this case again the first 3 to 8 decoder will be activated and pin output pin D7 will be at logic high. Accordingly, if suppose we are having all the inputs are at logic 1, say A1, B1, C1 and D1. So, in that case second decoder will be activated and the pin D15 will be at logic high. So, this way the decoder 4 to 16 can be realized with the help of 2 3 to 8 decoder with making a effective use of enable input. Now, we will see the design of 5 to 32 decoder from 4 3 to 8 decoder and 1 2 to 4 line decoder. Now, we have to consider a case where 5 inputs are there, and let us consider these 5 input bits are A, B, C, D and E, and in this case let us say E be the MSB and A be the LSB. So, first 3 LSBs are simultaneously connected to all the 3 inputs of all the 4 3 to 8 decoder, and the enable pin of first decoder is connected to the first output pin of 2 to 4 decoder. The enable pin of second 3 to 8 decoder is connected to the second pin of 2 to 4 decoder. The enable pin of third 3 to 8 decoder is connected to the third output pin of 2 to 4 decoder, and fourth 3 to 8 decoder pin will be connected to the fourth output pin of 2 to 4 decoder. So, this way what will happen, based on the 2 MSBs, right, any one of the 4 3 to 8 decoder will be selected, and based on the 3 LSBs, that is ABC, the corresponding output line, right, will be selected. For first 3 to 8 decoder, it varies from D0 to D7, and same way the last decoder has the last output bit as D31. So, based on the 5 input bit, right, the 2 to 4 decoder will select any one 3 to 8 decoder, and based on the input ABC, any one output of that selected decoder will be activated high. This way we can realize the 5 to 32 line decoder with the help of 3 to 8 decoder and 2 to 4 decoder. We can just have a look of truth table for this case. Please, next slide. In this truth table you can see these are the 5 inputs A, B, C, D, E, and the output line varies from D0 to D31. So, according to whatever the input that 5 bits are having, one output line is activated. This is the complete truth table for all the entries. Now, we will see the design of 6 to 64 decoder using 9 3 to 8 decoder. Here we have 6 input lines. So, let us consider D0, D1, D2, D3, D4, D5. These are the 6 input lines, and what we will do, we will have 9 3 to 8 decoder. Out of that, decoder 1 to decoder 8, all the input pin D0, D1, D3, D2 are simultaneously connected. So, 3 LSB bits of the input are directly connected to all the inputs lines of 3 to 8 decoder. So, one decoder will have 8 outputs. So, accordingly all the 8 decoder will give the 64 outputs, and 9th decoder will connect the 3 MSB inputs to this 9th decoder, and the output of this 9th 3 to 8 decoder will be connected to the enable pin of each 3 to 8 decoder. Say the first output of 9th decoder is connected to the enable pin of first decoder, second output line is connected to the second decoder, and this way all the 1 to 8 output lines are connected to 1 to 8 3 to 8 decoders. So, this way we can realize the 6 to 64 decoder with the help of 3 to 8 decoder, right, based on the inputs MSB of 3 bit, any one out of 8 3 to 8 decoder will be selected, and based on 3 LSB input, any one output of that selected 3 to 8 decoder will be high. So, this way we can realize 6 to 64 decoder using 3 to 8 decoder. Now, we will see the design of full adder using 3 to 8 decoder. You can see in the truth table, for full adder we have one input A, one input B and one carry input which comes from the previous state. So, this way we have the 3 input bits, and for full adder we have one output sum bit that we are calling S, and we have one output bit carry out that we will call C out. So, in truth table you can see the input A, B and C in will varies from 00 to 111, and accordingly when the input A is 0, B is 0, C in is 0, sum is 0 and carry is 0. When A is 0, B is 0 and C in is 1, so sum bit is 1 and carry is 0. So, accordingly this summation is done, right, that you can see with the truth table. When all the input, when A is high, B is high, C is high, sum is high and carry is also high. So, this is the truth table. In truth table you can see the bits that are high for S output and bits that are high for C outputs are highlighted. So, what we will do, this input A, input B and input C in is connected to the 3 inputs of the 3 to 8 decoder. So, then next we have to realize the sum bit. Now, see, when the sum bits are high, when the input is at 001 means at 1, when sum is high at 2, when the sum is high at 4. So, we will do what, all this case when the sum bit is high. So, that is 1, 2, 4 and 7. So, the output of 3 to 8 decoder of this 1, 2, 4 and 7 is connected to one OR gate, and this way we will able to get the sum bit. And for carry out, we will see when there is a logic high for carry out. So, that is for the output 3, output 5 bit and output 6 and 7. So, all these bits, for that the output is high or at logic 1. So, all these are connected to a OR gate to get C output, C out. So, this way the output sum and C output can be realized with 3 to 8 decoder. Only what care we have to take, for the case when the output is at logic high, that pin we have to connect to the OR gate. So, this way sum and carry out is realized. So, this way with the help of 3 to 8 decoder we can realize full adder circuit. Next we will see the design of full subtractor, again using 3 line to 8 line decoder. Again we will consider the input bits are A, B and one borrow input bit, that is B in, and the difference of A, B is considered as D bit and borrow out is considered as B out. The input A, B and borrow in will varies from 00 to 111, and accordingly the difference will be there. So, you can see the D bits, whenever the difference is high, D is 1, and whenever the borrow is high, B out is 1. So, we have to check when the D is high, and for that case the output line we need to connect with the OR gate for realization of D. See, in this case for output 1, for the case when the input is 001, the y1 is high. So, y1 is high, then y2 is high, then y4 is high and y7 is high. And this is interesting to note here that the logic high cases for sum bit and difference bit is same. So, all this output that are high will be connected to the OR gate to get D, and all the cases when the B out is high, all that outputs are connected to the OR gate to get borrow out. This way we can realize full subtractor using 3 to 8 decoder. Now, we will see the 8 to 1 mux using 3 to 8 decoder. Now, for this case the select line, in case of mux we need select line. So, for 8 to 1 mux we have 3 select line. So, all these 3 select line, let us say this select line S0, S1 and S2, these are connected to the input of 3 to 8 decoder, and enable is kept at high, and all these 8 output are connected to one input of AND gate, and another input of AND gate is connected to all the select line, say I0 to first AND gate, I1 to second, and this way I7 to the last AND gate, and all the output of this AND gate is connected to 8 input OR gate, and this way functions of 8 to 1 mux can be realized using 3 to 8 decoder. Now, we will see the implementation of functions using 3 to 8 decoder. So, 3 to 8 decoders are active high and active low, means when the output is line is selected, so that is at logic 1, so it is active high decoder, and if the output line is selected at it is there at logic 0, so it is active low decoder. So, there is a logic for selection of active high decoder with the function which is SOP or POS, and which gate that has to be selected, that you can see with the slide, that logic I have made. In this problem it is asked that implement the following function using 3 to 8 decoder with 2 OR gates, and the function f1 are there with summation m 1 2 4 5 and f2 function summation m 1 5 7. Now, he says use OR gate. So, see the logic, the equation given is SOP and it is asked to use OR gate. So, SOP and OR gate, so we have to use active high decoder. So, we will select 3 to 8 decoder, all the outputs that are considered as 1 2 4 5 will be connected to OR gate, and for second function output 1 5 7 are be connected to another OR gate, and this way this function is realized. Another example says implement the following function using active high 3 to 8 decoder, and function given is, it is a pause equation. So, what it says, active high and pause equation. So, for active high decoder, pause equation if we have to implement. So, NAND and NOR are the option. So, we can realize this function using NAND gate. So, outputs are 1, 3, 5, 7 of 3 to 8 decoder are connected to the NAND gate. This is the pause function is given and it is asked use active low. So, in case of active low and pause, we have options of AND gate and OR gate. So, we will make a use of AND gate, and whatever the terms that is mentioned 1, 3, 5, 7, the corresponding output bits are connected to the AND gate, and this way this function can be realized. Now, here it is says implement the following function using active low 3 to 8 decoder, and it is a SOP equation is given, summation of m of 1 to 5 7. So, active low and SOP equation. So, we have the options of NAND gate and NOR gate. So, we will make a use of NAND gate. Active low means all the output lines of 3 to 8 decoder will be bubbled, will have bubbled output, active low means. So, logic says active low it is asked. So, SOP equation. So, we make the use of NAND gate. So, all the output lines 1, 2, 5, 7 are connected to the NAND gate to realize this function. In this problem it is says implement the following function using active high 3 to 8 decoder and get the pause and SOP equation. So, two pause equations are given. So, it says active high. So, our logic says, you can refer this chart diagram. For active high and pause, we have the options of NAND gate or NOR gate. So, we will make a use of NAND gate and will connect the output 0, 1, 3, 5 to first NAND gate and the output 1, 3, 6, 7 to the second NAND gate to realize the pause equation. And then it says realize SOP also. So, we will convert the given pause equation to SOP equation. So, for first pause equation, what are the terms that are not present are 2, 4, 6, 7. So, these are the first function of SOP equation, and the terms that are not present in the second equation are 0, 2, 5, 6. So, that is the terms of second SOP equation. So, this way we have two SOP functions. So, for active high and SOP equation, we can realize using AND or OR gate. So, we will select AND gate and corresponding output of the function, say for first function 2, 4, 6, 7. So, all that is connected to the AND gate, and second function 0, 2, 5, 6, this output is connected to the second AND gate. So, we will realize this SOP function also. Next example says implement the following function using 3 to 8 decoder with minimum number of input to the in the external gates, and the pause equation is given pi m of 2, 3, 5, 7. Now, here logic says implement the following function using active low 3 to 8 line decoder for minimum number of input in the external gate. The given pause equation need to be converted to SOP equation. So, this SOP equation will be f of summation m of 1, 4, 6. Why? Because for 3 bit input we have total 8 terms, right. Out of 8 terms, 5 terms are present in the pause equation. So, obviously, the remaining terms will be present in the SOP equation. So, out of it 5 are present, means only 3 are there in the SOP. So, obviously, we will realize this function using SOP equation. So, we will have active high 3 to 8 decoder and will make a use of AND gate, and corresponding output that we are getting from the SOP equation are 146. So, 146 will be connected to the input of AND gate, and this will where we realize this function. Finally, to summarize, decoders are like the secret key to unlock digital door or pathway. They are an essential part of how modern electronics make the decision and handle information. So, next time you see a digital display, send a message or access your computer's memory, remember that decoders are working behind the scene to make it all happens. The 3 to 8 line decoder takes the concept of decoding digital signal to the next level by handling a specific 3-bit binary input and producing an output with 8 possible combination. Thank you.